Hey everybody, this is Mr. Schultz here with you, back for lesson 715. This one is also a little bit of a longer one too, so this will be a longer section here, but of course I try to keep them short so that they are more accessible here. But we'll take a look at it. I really liked this intro, so I'm going to cover it here. So, whose idea was it to measure a degree in angles? That's a great question. Why are there 360 degrees in a full term? Well, this is actually from 4,000 years ago from the Babylonians, and they had a sexagesimal system that was a base 60 system. So we have a base 10 system. So if I write the number 101, I've got 1 in my ones category, I've got 0 in my tens, and I've got 1 in my hundreds. But they had a base 60. So 101 in base 60 would have been 1 in the ones category, 0 in the 60s, and then whatever 60 squared is 3,600, I believe. 1 in the 3,600s. So that's what they mean. That's why they did stuff in 360, because you could split. You can put 360s into 60 pretty simply there. So if you're like me and super awesome, you think stuff like that is super nerdy and super fun, but that's why we have it. So we use 360, but we don't have to. We also have another thing called a radian. I hinted at this in the last lesson, and we're going to take a look at that and go from there. And so using radians is just another form to measure things like a degree is. It's just another unit of measurement. It would be like measuring something in miles and measuring it in kilometers, where, radians would be in that kilometers, miles would be in that degrees, much like that, or vice versa. Something like that you can go back and forth with. So let's take a look what this looks like. Okay, so what word are you reminded of when you hear the word radian? Radian, I'll let you think about it. Spoiler alert, radius. It's going to be built on the idea of using a radius. So let's see how this works with a little bit of an art project here that I won't have you do, but I'll show you what I did with it. Okay, so on 72 here, you do a lot of like cutting and pasting, or not pasting, but it's like drawing and cutting out and things like that. So you're supposed to get some sort of a circular object and some scissors. So I used a Pringles lid, and then you take and you cut that out and you fold it into you fold it twice. So here's mine. It looks something like that. Let me use a different color here. Yes, and folded, it looks something like that. And the reason we did that is because this gets you a radius here. So we went. This is our first step. We went and we traced all that stuff, and we did that. So let's see what our next steps are here. Okay, so now we're to our second step. We're supposed to take and draw another circle, and then you're supposed to take the radius edge. So that would be this edge here is a radius, and I'm going to wrap that, around my circular object. So I took that radius and I wrapped it around this circular object right here. So this curve here now is the same. This is the radius. It's the same as that right there. So then to finish off, it said to continue to marking them off until you've gone around the entire circle. I stopped here for a deliberate reason, and that reason is to kind of show you that, hey, remember back when we had the circle stuff, and we were trying to figure out the circumference and things like that. Well, remember that circumference was pi. Was pi times by the diameter. That was the circumference. Well, that's also the same idea as 2r, because 2 of the radius is the diameter, times by pi would equal the circumference. There's a ratio here between these things, and you might notice that, hey, if I put that on there, which my line isn't perfectly straight, but it's close enough, there are 3.14 radiuses to get to halfway around the circle, or 180 degrees. And that's interesting because, again, we see that pi number kind of popping up here. So that's kind of the whole point of this here, just to recognize that the reason we're using a radian is because it's based off the radius, and the radius has a relationship to the whole circle that is based off of 3.14 or pi. That's kind of the whole point of this. So if you read these directions kind of like, wait, cut what? Like, do this thing. The whole point of it is just that a radian is based off the radius of the circle, and it's the same degree measurement every time. And that's that. So that's everything that they wanted you to get out of that first problem there, problem number 72. Let's take a look at 73 here. So now we're going to get into just kind of using this stuff. So it says, assume that the radius of a circle is 1 is 1 unit, or just 1. Okay, well, the radius, so I'm just going to go and just say that halfway across, that's equal to 1. Well, to find the area, that's just pi times by r squared, so that'd just be pi. What's the circumference? Well, the circumference would be 2 pi r, or 2r pi, because 2 of the radius, so 2 times 1, so the circumference would be equal to 2 pi. And we could always write this as the decimal equivalent too, but I'm kind of lazy and I don't really want to do that. But it would be 3.14 and 6.28. But again, doesn't really have to be. So jumping back to this, how many radii, or how many of the radius would it take to wrap completely around the circle? It would take 6.28 of the radius to wrap completely around a unit circle, because each of these is based, again, going back in that radian thing, I should end up having that, which was some of that picture that I was showing you on the last one. Let's actually jump back to that. So here we would have 1 of the radius, 2 of the radius, 3 of them, and then hint, hint, this will be 0.14. So again, if I have 1, 2, 3 on the other side plus 0.14, there's where we get that 6.28. So we just see that it is pi radians. Pi radians. Does the size of a circle matter? Hint, hint, no, it doesn't, because the radius is always going to be based off the center to the edge. So even if it's a really big circle, this is not even that big, that same distance is still going to end up being that same pi number. So it doesn't matter. So exactly how many radians are there in 360? There are two pi radians, meaning that there are 6.28 radians in 360. How about in 90? Well, you just need to split that into fourths. So I might call that actually half pi radians, which would involve taking 3.14 and dividing it by 2. Not really something I'm super interested in, but I guess I'll do it. 1.57? If that's right. Yeah, 1.57 radians there. Okay, so let's summarize this idea of radians in everybody's favorite, a learning log. Let's check it out. So now in this one, how is a radian related to the radius? It is the radius. A radian is the radius, but curved on a circle. So it's curved on the edge of a circle. Whereas a radius just goes from that center to the side, or to the rim, as some people might call it. So just making that idea that the radians is not just some random unit of measurement that we decided, it's based off of the radius. Okay, let's go to question 75 here. Okay, so on this one, we're just going to start to go back and forth now between degrees and radians and compare these things. I think this is an awesome problem to do here, because there's just so much comparison there. So in degrees, 1 degree, if I'm going to draw my kind of 1 degree, well, there should be 360 of these. So it's maybe like 1 degree. Whoops, not percent. Sorry, 1 degree. But a radian is based off the radius. We know that there's 3.14 or pi radians. And so what that tells you is that if there's pi radians is equal to half of a circle, so 180, we can find out what that kind of degree is, and maybe that'll help your brain kind of translate. So doing some rough math, it's about 60, but it's a little bit less because I need 3.14. So the exact measurement there, it's 57.2958. Well, we'll call it, it's about 57 degrees. So it's a little bit less than 60. I'm going to do my best here to draw a 60. Let's see what it looks like here. Also, this center looks a bit off. Let's go right here. So let's call, I don't know, 1, 2, that's maybe a little short, but roughly about 60 degrees here. So here is 1 radian, which I'm going to shorten to be rad, which is also very rad. So I've got those two. Let's jump to problem C. We'll do a different color here, so I'll jump this over in pink now. So pi radians, well, remember we kind of saw that from our image, so that is equal to 180 degrees. So that goes all the way across the circle. Just for kind of ease here, I'm going to just write these out here. It's roughly about 57, not percent, I keep writing percent, 57 degrees 180 degrees, and so on and so forth. Pi over 2. Okay, so if this is pi is 180, well, I need half of that. Well, that should be 90. Let's, again, go to a different color here. So hopefully I can get there. So this will be here. This will be about 90 degrees. So we're just going to go right down there for pi, or pi over 2 radians. Again, we're going to cut that in half again. So that should be about 45, which is closer to where I've got my blue line right here. My blue line for 1 radian is 60. It should probably be more like that. Okay, so I moved and erased that old line because my 60-degree line just was not super great. And again, that's approximately 60. So there's that. So now I've got that. Now we're going to figure out pi over 3. Pi over 3. Okay, so pi over 3. I'm going to think about this. So if pi, so 3.14, so I'm basically splitting 180 into 3. Hey, this is actually going to be very close to my 60-degree mark. So I'm going to put this just a hint past here. Because remember that 1 radian, that blue line, is about 57 point something. But pi over 3 radians, that should be exactly 60 degrees there. So I'm just kind of writing these out here just so you can kind of get your head around what's actually happening here with each of these. And then pi over 6, that'll just be half of 60. So I'm talking about a 30-degree angle. Let's watch and mock Mr. Schultz more as he tries to make a 30-degree angle. That one's not too bad, I don't think. So there's your 30-degree angle. So here's the big key. We almost never use like normal numbers with a radian, like 1, just because it just doesn't really fit like super well. But we use pi with it all the time because it fits so perfectly, exactly perfectly across the circle, or 2 pi radians fits the whole circle. So we're generally taking pi and splitting it into these fractional things to talk about these different angles when we're using radians. All right, let's take a look at our very last problem here. Okay, last one. Problem number 76 says this. Find your signed calculator, the resource page. We've been using the e-tool, so I've got screenshots of that up here. Use your new understanding of radians to convert the units on the theta axis from degrees to radians. So right now, in the theta axis on the previous here, we had it going by 180, 210, 240. All these are degrees. 180 degrees, 210 degrees, 240 degrees. So if you open up the little gear here and you switch it from degree to radians, like in here, your graph's going to pop up and show like this. And it's good, and that's like, well, what the heck? Well, that's because you're talking about now 180 radians. Well, we know that 1 radian is roughly 60 degrees. So of course, there's all kinds of back and forth that is happening here. So we also need to adjust our x-axis to account for that. So on this graph here, I've now changed it to be something a bit smaller here. And notice again, here's that one. So at 90, it's right around that like 1.5. Bo said it was 1.57 is about halfway. 3.14 is 180. So this has gone a full 180 here. And so on and so forth is going to keep going. So just know that when you change from a degree to a radian, you'll probably also have to change your x-axis to accommodate for that, unless you're really into seeing a bunch of squiggles like that. All right. That is everything here. Check out the review and preview in the section and let me know if you have any questions. Thanks. Bye-bye.